Our next contestant is Hans Oberschelp.
When you type your password into your bank's website, you want to be certain that it's stored securely. Otherwise, a hacker could steal your password and drain your bank account. That's why banks and other companies use encryption algorithms to scramble their data into a secret code that only they know how to read. But how do we know that these secret codes are so secure that no hacker could possibly decode them? Well, the trend has been to use algorithms with no known vulnerabilities and just take their security on faith. I'm working at the UC Davis Math Department to mathematically prove that some algorithms are impossible to crack. And I'm doing this by shuffling cards. Now, let's talk about what goes into a good card shuffle. This is a new deck of cards in its original order. One way I could shuffle this deck of cards is just by cutting it at a random depth. Now I have no idea what this top card is. Let's take a look. Turns out it's the 3 of clubs. Ask yourself, is this a good way to shuffle a deck of cards? No. Even though I didn't know that this would be the 3 of clubs, after seeing it, I know that the next card is the 2 of clubs, and the next card is the ace of clubs, and the next card is the king of hearts. If I wanted to more thoroughly shuffle a deck of cards, I could use the swap or not shuffle. Each round of the swap or not shuffle works by pairing up the cards in the deck and then deciding to swap the cards in each pair or not using a sequence of random coin flips. My advisor and I mathematically proved the exact number of rounds it takes for the swap or not shuffle to get so random it's basically unbreakable. In essence, we showed that after doing the swap or not shuffle for a modest amount of time, I could show you the entire top part of the deck, and even with this information, you would have no idea what order the rest of the deck is in. Okay, but what does this have to do with encrypting data? Well, let's say I'm your bank, and I have some data I need to encrypt, like some passwords. I could assign every possible password to a card in a gigantic deck. Now, by shuffling this deck, I scramble the passwords. Because we've shown that the swap or not shuffle mixes up this deck of passwords so well, we know that the algorithm can't be broken. Now, in real life, banks aren't going to scramble their data by hand, they're going to use computers. But what's great is that the swap or not shuffle can be simulated very quickly using computers. This means that using our research, organizations can develop encryption algorithms that can quickly encrypt their data, and they can be certain, mathematically certain, that their data is safe and secure. Thank you.
So this is very interesting, and I love the giant pack of cards. Do you ever play with the pack of cards?
I paid for it using the gift card I got for registering for the Grand Slam.
Excellent. A good use of money, for sure. Now, how did you get into researching encryption?
Yeah, so I started grad school just studying pure math. I wasn't even totally sure which field of math I wanted to do. Eventually I ended up doing probability, but I thought maybe I would do number theory. Mm-hmm. And it started out that I just didn't want to take too many classes because I was really stressed out and there were these hard classes I was taking, but I had to take 12 units to get my TA-ship. So I was like, okay, I'll do a reading course, I'll read through a book. I had taken a Professor Ben Morris's class previously, and I knew him, I really liked his class, so I asked him if I could work on something, and eventually I ended up kind of getting into this research project with another graduate student, Hamilton, who he was working with, mm-hmm. And so at the end of the quarter, I was like, okay, great, I got my units, I have 3 classes I want to take next quarter, so I'm done with that, and then at the start of the next quarter, I got an email, what time are we meeting? So I mean, I didn't want to be rude, so I just, okay, we'll meet at this time. And then I just kept doing that for years, and eventually Ben Morris became my advisor, and here I am today.
Well played, I will say. That's wonderful. And then, why UC Davis for your PhD in mathematics?
Well, I actually went here for half of my undergraduate, so I transferred here, and I really liked it here, and I applied to lots of grad schools. I got in here, I got into some others. When I went to the other graduate school, I guess it's okay to say, like LSU, and I went there. And I really liked it. No, I really liked it. I was seriously considering going there. And I talked to a student there who had also come from UC Davis. And he said, oh, well, I came from UC Davis for my undergraduate. I'm in graduate school here. And he said, LSU is a really good school. I really like it here. But I think I would have liked it a little more if I had stayed at UC Davis. So, I mean, you don't get many opportunities in life to get that kind of advice. So.
Well, we're glad you're here.
Thank you.
Great. Well, thank you very much.